All right, so this is the last lesson we have for Unit 1. This one is using composition of functions to prove inverse. Now we have very quickly talked about composition of functions when we did function notation a couple days ago. So let's just kind of review what a composition of function is. A composition of function is when we plug a function into another function. When we had f of f or when we had f of g. So plugging one function into another function to create a new function. So plugging one function into another. And how is it presented? You could see it, when we do it, we're using two equations, so you could see this one of two ways. You could see it as this, f with a little circle. It's not an O, it's a little circle. So f of g is how you say it, or you can see it as f with a parenthesis, g, parenthesis, x, double close it. And how we say it again is f of g, or f of g of x. Now, you also can have the other way. You could have it of g of f. Again, that's a little o, little tiny o, not an of. G of f, which is the same thing as saying you have g of f of x. And again, that's how you say it, g of f. So how can this be used? We use composition of functions to prove inverse, and we're going to get to that today. Last class we talked about what an inverse is, how to find it, but sometimes if you just have two equations, maybe you want to prove that they're inverses without like plugging in ordered pairs and seeing if they fix it, but also just generally you use composition of functions to create some new functions. So this is just kind of a step-by-step so that you can kind of hopefully see how these two things are related and what you should be getting if they are inverses of one another. So if I have the function 9x plus 4 and I want to find f of 2, that means I'm plugging in 2 into x. So that is going to be 18 plus 4, so that's going to be 22. So that means I have the ordered pair 2, 22. So now it says, let's find f inverse of x. So going through the steps, rewriting f of x as y, switching it, I am just going to put those two steps together here. So you have x is equal to 9y plus 4, getting y by itself, subtracting 4, dividing by 9. So you get f inverse of x, or y, equals x minus 4 over 9, which I'm happy with, or f inverse of x is equal to x minus 4 over 9. If you want to write 1/9 x minus 4/9, go for it. That's a lot of extra fractions that I don't like. So step 3 says now let's call f inverse g of x. Okay, so g of x is now equal to x minus 4 over 9. All I did was just create a second function. G of x is equal to x minus 4 divided by 9. So now I'm going to find g of 22. So I'm going to plug in 22 into my g equation. So 22 minus 4 divided by 9. 22 minus 4 is 18. 18 divided by 9 is 2. So that's going to give me the ordered pair 22, 2, which makes sense. It should. Those should be opposites of one another because they are inverses. Inverses means your x's switch. So now this last one says find f of g of 22. So we already have g of 22. Let's think smarter, not harder. Let's not plug in 22 again. We have g of 22. G of 22 is 2. We just found that. So now what I have is f of 2. Which we have found already. F of 2 we found at the very top of this set of notes, set of examples. F of 2 is 22. So f of g of 22 is equal to 22. So when you have an inverse, and we have an inverse because we used an inverse, so when you have an inverse and you input a value into the composition of functions, when you are using the inverse equations as a function, as a composition, what are you going to get? So what I mean is this: when I had f of g of 22, and I know f and g are inverses of one another, when I inputted a 22, what did I output with? 22. If I were to input a 13, I would output with a 13. If I inputted a negative 674, I would output with a negative 674. If I input an A, I'm going to output an A. They're going to always input and output the same value as long as they are inverses. So let's use that idea by finding f of g of x. Now, what did we just say? If we input an x, and these are true inverses, I should output with an x. Your input and your output should be the same if they are inverses of one another. And when these are, because we just did this. So find f of g of x. Now, these are a little bit different than the ones we had before. When we had numbers, we would always start with the insides. I can't start with the insides this time because I have an x as an input. So g of x is a whole piece in itself. So what this means is g of x is my input onto f. So I'm now going to put g into f. I'm going to put all of g into f as the input. So I'm starting with the 9. I'm starting with the f of x, which is 9. Then I'm getting to my input. My input is my g, x minus 4 over 9. And then I'm going back and finishing and putting plus 4. Distributing that 9, although I don't really need to distribute it, I can just cancel out the 9s. And then I have x minus 4 plus 4, which cancel, which just gives me x, which I knew it should. I knew it should because I did those as inverses, and so it should equal x. Now finding g of f of x. So now f is getting plugged into g. Again, f, the 9x plus 4, is getting plugged into the input onto g. So plugging in, starting with g now. G starts with the parenthesis, the minus 4 on the top, and the 9 on the bottom. But now the x is 9x plus 4. The input is now 9x plus 4. My plus 4 and my minus 4 cancel out, so I have 9x over 9. The 9's cancel out, and I have an x. So using composition of functions, what will always be the result if you have an inverse function? If you are plugging in x, and these are inverses using composition of functions, you are always going to get x. If they are inverses, you are always going to get x for both, and it is important that you do both. So, second page, now is when, instead of giving you one equation and saying, find the inverse, now I'm giving you two equations and say, proving are they inverses. So when I do these, I first kind of do a mental check. Do they have opposite operations? Multiplying by 2, multiplying by 1/2, yes. Adding 1, subtracting 1. They do have opposite operations. Now, are they in the right order? Don't know. So let's use composition of functions to prove if they are inverses of one another. So we're going to do f of g of x first. So that means g is getting plugged into f. And I'm going to use some highlighters this time. So g is getting plugged into x. So I have my 2, and then I get to my input. My input is g of x, which is 1/2 times x minus 1. It's going to get really interesting with all these parentheses. And then I need to go back and finish and put plus 1. So the 1/2 times the 2 cancel each other out. When I distribute the 2 to the 1/2, that cancels. So I have x minus 1 plus 1. Then the minus 1 plus 1 cancel each other out, and so I'm just left with x. So on f of g of x, it is proving that it's an inverse, but I still need to do g of f of x. So now, instead of g being my input, f is my input, and f is going to get plugged into g. So I'm starting with a 1/2 in a parenthesis, going back and putting 2x plus 1, and then minus 1 still in that parenthesis. So the minus 1 and the plus 1 are going to cancel each other out, and then the 1/2 times the 2x are going to cancel each other out. And so again, I am just left with x. So yes, these are inverses of one another, proven because I did f of g and g of f. All right, second example, I have 2x squared minus 4 and the square root of x plus 4 over 2. So I was originally multiplying by 2, inverse, dividing by 2. That seems to check out. Squaring, square rooting, that checks out. Minus 4 plus 4, that checks out. Everything checks out as far as opposite operations. Let's see if they end up being inverses when I do f of g and g of f. So f of g, if I have f of g of x, so I'm going to do it as writing it as f of g instead of f of g of x this time, because you could see it either way. I'm more of the first way because then I can really see which one's my input. So if I have f of g, that means g is my input onto f. So all of that g is going into my input. So I have 2 and then parentheses, the square root of x plus 4 over 2 squared minus 4. So this one you just got to be a little bit careful with PEMDAS. PEMDAS says you would do that squared part first. So I'm going to square it, and when you square both the numerator and you square the denominator. So my numerator squaring a square root is going to go away. So I still have the big 2 out in front. My numerator is going to become x plus 4. My denominator is becoming 4, and then subtracting 4. 2 and the 4, the 2 out in front and the 4, that becomes 1/2. So I'm going to have 1/2 out in front, and then I have x plus 4 in parentheses minus 4. When I distribute that, I'm going to get 1/2 x plus 2 minus 4, and that's not going to give me x, no matter which way I try to do some more math. Could you stop that math beforehand? Yes. Right? Do you still have to do g of f? Yes, you should still do g of f. So now f is getting plugged into g. So plugging in all 2x squared minus 4 into now that radical. So I have the square root in the numerator, the square root of, and 2 in the denominator, 2x squared minus 4, and then plus 4. Well, my minus 4 and my plus 4 can cancel. They're both underneath the radical. That's allowed. So I have the square root of 2x squared over 2. The only thing that's perfect that can come out of that radical is the x squared. So that's x over the square root of 2 over 2, which can't reduce any. And so no, again, I have proven that these are not inverses. So while they did have opposite operations, there was something about the order of those operations that did not make those true inverses of one another, and I proved it using the composition of functions. So if f of g is equal to x, what is g of f going to be if they're inverses? It's always going to be x, okay? If you do f of g and they are inverses, then the g of f will be an x. They are not going, one is not going to work and the other one not going to work. They both work or they both don't work. So is it still necessary to do both? Yeah, it is. It is still necessary to do both because you could catch a math error. You make math errors all the time. I make math errors all the time. So you could make a mistake on one and catch it on the second one because they either will both work or they both will not work. If they work on one and they don't work on the other, then you have made a mistake on one of them. Or if it doesn't work on the first one and then suddenly it works on the second one, again, you have a math error somewhere and you need to do both of them again to see which actually is the true inverse or not inverse.